Hi everyone. In this video, I am going to tell you about an encoder. Encoder is nothing but a digital circuit. Most commonly, encoder, decoder, multiplexer are used in the communication purposes. Okay. Encoder and decoder are both quite opposite to each other. Encoder is used to represent a big data, large data into a single uh, coding format. Okay, encoding is nothing but large data is represented in a coding format, that is encoder, whereas the decoder is nothing but which is an opposite action of this encoder, where the code is going to be again elaborated into its original form. Okay, suppose in general encoder is nothing but a digital circuit. Encoder is a digital circuit. Encoder is a digital circuit mainly used to compress the data. Compress the data. Okay, it is the having an application in communications. Communication, because when we are transmitting a signal and we are transmitting a data secretly from one place to another place long distance, then we have to encode the data. Encode the data. That means a big information will be compressed into a small data and then it will be transmitted. Once the receiver receives this, it will be again opposite action will be performed there, nothing but decoding. Okay, so encoder has, the main important thing is encoder has 2 power n input lines and n output lines. Okay, so 2 power n input lines and then n output lines. So that's why the size of an encoder, is 2 power n by n. 2 power n by n. This is what the encoder is. Encoder is having a size of 2 power n by n, where n means number of outputs. Number of outputs. So for example, 8 to 3 encoder, 8 to 3 encoder, 4 to 2 encoder, 4 to 2 encoder, and again 16 by, it is 4 encoder, and then 32 by 5, 64 by 6, like that we are having different types of encoders. Okay, so encoder is nothing but a digital circuit that is used to compress the data. Used to compress the data means, here see here 8 bits of information is just replaced in terms of 3, and 4 bits of information is converted into 2 bits, 16 bits into 4 bit, like that we are having number of examples. So now if you take this 2 power n number of inputs, encoder has 2 power n number of inputs and the outputs are n number of outputs. N number of outputs. So it is 8 to 3 encoder. Okay, this is what the size of the encoder. 8 to 3 encoder, or general example 2 power n by n encoder. It is one example. 8 to 3. 8 to 3 is having 8 input lines and 3 output lines. Okay, let us first see an example. Octal to binary encoder. Octal to binary encoder. Octal to binary encoder. Octal is nothing but total is 8. So 0 to 7 we are having in octal D0. If you start D0 to D7, octal means D0 to D7, D0 through D7, and binary information is nothing but as the same corresponding number is going to be 000 to binary means 000 to 111, 000 to 111. 000 means 0, 111 means 7. So in that way these two are related. Okay, so now what is the purpose of this octal to binary encoder is it converts a single bit in particular location will be converted into a binary format of that location number. Suppose we are having 0 to 7 input data. Somewhere at D5 we are having 1 and remaining all are zeros. Then as D5 is 1, the corresponding fifth location will be highlighted. So like 101. Okay. So with this, let us first draw the truth table of this one. So octal to binary, we are having octal numbers we know 0, 1, 2, 3, 4, 5, 6, 7, and binary is having 3 bits of information. So binary means A2, A1, A0. So 0 means 4 zeros, 1 means 0 0 1, 2 0 1 1, 1 0 0 1 0 1 1. Sorry, it is 0 1 2 3. This is 1 0. This is 0. So 0 1 0 0 1 1. 0 1 1, and then 1 0 0 1 0 1 1 1 0, and then 111. Okay, so this is the truth table of the octal to binary conversion. So octal number we are having here 0 to 7. Octal means 8, maximum is 18. So 0 to 7 is 8, and we are having a conversion in terms of its binary data. So how to get the expressions and the truth table expression and the logic circuit diagram for this type of circuits? So wherever we are having ones, take them and all of them must be added. So A2 is equal to, how can you say that A2 becomes 1? A2 is having 1 in 4 different places. That is 4 5 6 7. 4 5 6 7 are nothing but simply D4 plus D5 plus D6 plus D7. And A1 is equal to D2 plus D3 plus D6 plus D7. A0 is equal to D1 plus D3 plus D5 plus D7. If you observe carefully, we don't have D0 in any of these cases, but D0 is there in the given octal numbers. So the D0 most commonly it is considered as the don't care. So here we have 3 OR gates. So here we have A2, A1, A0. These are the binary outputs. Here we have D1, D2, D3, D4, D5, D6, D7. So D7 as it is 1 and has all the connections. And similarly D6 is 1 0 1 1 0. So A2 is 1, A2 is 1 and A1 is 1. Okay, and D5, 5 means 101. So it is 1. This is also 1. Next 4 1 0 0. 1 0 0 because D4 means A1 only, A4, A2 only. D3 means 3 means 0 1 1 0 1 1. So these two are ones. A1 and nothing is there A0 because A0 is simply 0. And next one 2 2 means 0 1 0. So only A1 is there, remaining are not there. And D1 is nothing but 0 0 1. So this is the way of designing the logic circuit for octal to binary encoder. What is this? Octal to binary octal to binary encoder. Thank you.